Welcome back, guys. Back with another banger. This time we're going to be reviewing Unit 5, okay? So we're going to be going through some questions, not hard, okay? This time we got two special guests. We got Alonzo and Jaden.
Alright, what's up, guys? Unit 5 review, it all comes down to this for this unit, alright? Unit 5, probably one of the hardest ones, but we're gonna get through it. We're gonna smash this test, just like how I smashed your mom. Alright.
Yeah.
Let's
All
go,
right.
Jaden. So,
Quick
number one.
disclaimer. Wait, quick disclaimer. So maybe like 15 minutes in, I didn't realize we weren't recording. So we're just gonna leave up the work we already have and just like quickly explain it. All right. So Alonzo's gonna be doing number one. And I'll be doing next set of questions.
Alright, so, number one, alright? It's trying to correctly order from least to greatest, f of 2, f prime of 2, and f double prime of 2. Alright, so, let's see what we know. Alright, so we're given the graph of f straight up, right? So, we know that f of 0, or f of 2 is going to be 0, right? Boom, 0. Alright, now let's move on to f prime of 2. Alright, so what is prime? Alright, that's the derivative, okay? So, the derivative is the slope of the tangent line, right? So, where is this graph going? Is it going up or is it going down, right? So, we can draw an arrow here. It looks like it's going down, right? This would be where the graph is going. If you keep going straight, it's going down. So, that means f prime of 2 is going to be negative, right? So now let's look at f double prime of 2, right? So, actually, give me a sec. Just alright. Boom, bam, bob. Alright, so, now we have these two, right? Let's go f double prime. So, we know that the graph is going down, but look, it's starting to go up, right? So it's getting pulled up, and that's the second derivative. Is where the it's how it's affecting the rate, the slope of the graph, right? So the slope is going up as you move along the x, right? So that means when it's going wants to go up, it's going to go positive as their second derivative. And so now we can order these. F prime is negative, so it's less than 0, or f, which is less than f double prime, and that's how you do number 1, which is C. Boom.
Alright, guys, we're gonna go with number 2, 3, and then some other questions. Don't mind the lag, if there is any, but we're gonna continue with what we have. Alright, number 2. Rectangles bounded by the x and y axes and the graph of y equals 6 minus x over 2, as in the figure below. What length and width should the rectangle have so that its area is a maximum? So basically, it just means what are the largest length and width to have like the highest area. Alright, I'm gonna visualize this or just already draw it as shown. So we got our little rectangle, and then we got the function, okay? Let's just say it's like touching right here. We have a length of x. We don't know what the exact number is, okay? And then our width, that's just gonna be our function, or our width is just gonna be 6 minus x over 2. So we gotta find what our length and width is gonna be. In order to do that, we know that area is gonna be length times width. So if our length is x and our width is just 6 minus x over 2, that's just x times 6 minus x over 2. And that's just 6x minus x squared over 2. And then I'm gonna simplify that, so that's just 3x minus 1/2 x squared. Now, what I'm gonna do is I'm going to take the derivative of this and set it equal to 0. So I'm going to get 3 minus x and equals 0. Immediately I can see that x is going to be 3. So the largest length we're going to have is 3. Now we got to find our width. In order to do that, we're just going to plug in 3 back into our original equation, 6 minus x over 2. So if we do 6 minus 3 over 2, and it's a y equals, this represents our width. This just equals 3 over 2. Therefore, our length must be 3 right here, and then our width must be 3 over 2, Easy. Alright, number 3. I already did the work, but I'm going to explain it. So I'm going to read the question out first. So it says let f of x be a strictly increasing function such that f of x is less than 0 for all values of x. Let g of x be a strictly decreasing function such that g of x is greater than 0. If h of x equals the product of f and g, which statement is true? Alright, so I underlined some important things here, okay? So, f of x is strictly increasing, meaning that the derivative is greater than 0. So it's going to be some positive number. F of x is less than 0, which means that's going to be some negative number. So it goes the same thing with g of x, it's just opposite. So the derivative of g is going to be some negative number, and then g is going to be some positive number. So I'm going to first solve for the derivative of h of x. So we know if it's strictly increasing or strictly decreasing, so that's what I did. In order to do that, I did the product rule. So I did h prime x equals f prime x g prime x plus f of x times g prime x. So f prime x is some positive number, g prime of x is some positive number, and then f of x and g prime of x are two negative numbers, but they both multiply to become a positive number. So you got one positive number right here, adding up with another positive number. Therefore, h prime of x is going to be some positive number, therefore meaning it's greater than 0, or just strictly increasing. So that means our answer choices would be A or C, and then I'm going to explain how I got C for this part. So, all we had to do is just multiply f of x and g of x. So, if we know that f of x is some negative number and g of x is some positive number, we know that it's going to make some negative number, meaning h of x is going to be less than 0. Therefore, h of x is going to be less than 0 and strictly increasing. Alright, so now Alonso's going to go on to the next question, explain how he got it.
Alright, so we are dealing with optimizing the cost for a right circular cylinder, alright? So let's draw that thing out. Here we go. This is what it's looking like. So, it's designed to hold 22 cubic inches of liquid. So that means our volume is going to equal 22, or 22 is going to equal the volume of a cylinder, which is pi r squared times height. So that was the easy part. So now let's see the cost of each part of the can, right? So we have the cost of the material for the top and the bottom of the can is 2 cents per square inch, right? So let's figure out for each area in the can, it's going to be 2 cents, right? So for the top, so we have two circles, right? Or first, let's ask ourselves the area of each circle, right? So each area of the circle is going to be pi r squared, okay? And we have two of them. So we have 2 pi r squared times 0. Actually, let me just move this up a titch. Alright. God damn it. Do that. Alright. So, for each area, we need to pay up 0.02 dollars or 2 cents, right? So this is top and bottom, T and B. And so that's calculate the cost of the side, which is for each one, or each area, we gotta pay up 1 cent. So 0.01 times the area of the side, which is given to us as a 2 pi r h. So we gotta add these together to get the total cost. So 0.01 2 pi r h plus 0.022 pi r squared. So we got these two formulas, right? And now let's see which ones they line with. And if we, the hardest part is probably looking for them. So yeah, it's gonna be C.
Alright, I'll be doing the next two questions. Alright, so number 9, it literally just like asks like You know what? Let me rephrase this. I'm going to read the question first. Use a graph of f on the right to estimate the value of c that justifies the mean value theorem for the interval 0 to 7. If you forgot what the mean value theorem is, it just literally means when the average rate of change equals the derivative. Alright, so basically, our average rate of change is from 0 to 7. So this blue slope that I circled, okay? We know the slope is positive. We don't know what the exact slope is, but we know it's a positive slope. So it's basically just asking us what value of c will have the same slope, okay? So, or just the value of x. It just means like x equals c, alright? So, when I check d, remember, with the mean value theorem, when you take the derivative, you cannot include your endpoints anymore. So it'll be open brackets, so it cannot be d. And then, with b and c, when I graph them, or just like try and like make some similar slope, they're both negative right here. When I both graph them or just drew them, they're both a negative slope. They're not the positive slope that we're finding. So therefore our answer is A. When we try and draw the slope at 3.7, it's like a similar slope between our average rate of change that we drew. Alright, next banger question is number 10, alright? This is another optimization question. I already did it, so I'm just going to quickly go over it. So it says that some people are designing a square bottom or a box-shaped aquarium with a square bottom and then an open top. So the open top means that we're not even going to include this top part of the square. And then we have a square bottom, meaning like the bottom part of this cube, or I will say box, is going to be a square. So that means it's going to be x times x. So we want to find our surface area and then our volume. So what I did was, in order to find the surface area, that just means like the sum of each area of like the face. So if we know we have 4 of the same sides, x times y, that's going to be 4xy. And then we have the bottom, so that's going to be 4xy plus x squared. That's our surface area. And then our volume is just x times y. So x squared y, or length times width times height. And that's going to equal 500. And with that, the answer was B. Okay? Should be pretty easy. Alright, so now Alonzo's going to go up to number 11, and then we got a couple more questions to finish up.
Alrighty, so number 11, alright, is asking us, right, gotta find the interval in which the function they give us, x squared minus x minus 12, where is that increasing? Alright, so, if you just function looks a little bit like this, right? So visually you can see where it is, but let's use calculus, right? So it's asking us where it's increasing, right? So what will tell us where it's increasing or decreasing? All right, so that would be the derivative, right? So we got f of x equals, here, I should just kill this graph. We don't need that. I know I drew that. Let's move this over here. All right, f of x equals x squared minus x minus 12, right? If we derive it, you get 2x minus 1. All right. So, we want to see where it's positive, right? So, looking at this, we know that as we go right, we're going to be more positive, right? So if we were to plug in like 1, we would be going up 1, right? So f prime of 1 equals 1, right? And f prime of 2 would be 3, right? So that means our right bound is going to be infinity. And so now we need to find our left bound. So we're going to set this equal to 0. So 2x minus 1 equals 0. 2x, and that's going to give us x equals 1/2. And so our answer will be, very important that we put the parentheses here rather than a bracket, and then to infinity, and then another open bracket. And that's our answer.
Alright, we got number 12, okay? This is going to have to do with the mean value theorem, okay? So, it says that f of x is differentiable everywhere, and that f of negative 2 equals negative 5, and that f prime of x is less than or equal to 5. And it says that using MVT, what is the largest value or largest possible value of f of 8? Alright, so remember that mean value theorem is just f of b minus f of a over b minus a, which equals f prime of c. Alright, so f prime of c is going to be less than or equal to 5. So I'm going to write this as less than or equal to 5, right? And now we got to replace b and a. In order to do that, we have a coordinate, negative 2, negative 5. We got negative 2, negative 5, and then we have f of 8. So we got 8. Okay, so in order to do this, we are going to do, and let me just say that this is going to be our f of b, and then our b as well. We don't know f of b, by the way. We just have b. And then this is our f of a, or let me just do this. So we got a, f of a. Alright. And it says, what is the largest possible value of f of 8? So that's what we're solving for. So here's what we're going to do. We're going to do f of 8 minus f of negative 2 over 8 minus negative 2 less than or equal to 5. And then we know that f of negative 2 is just negative 5, so f of 8 plus 5 over, and then 8 minus 2 is just 10, is over 10 less than or equal to 5. And then what I'm going to do is multiply both sides by 10. F of 8 plus 5 is less than or equal to 5, or 50, sorry. Subtract 5 by both sides. That means that f of 8 is going to be less than or equal to 45. So our largest possible value is 45, meaning our answer choice is B. So now Alonzo's going to do the next 2 questions, and then I'm going to do the last 2 questions.
Alright. So, alright, so we're doing number 13 here. Alright, for all x, alright. Alright, so we're given a table here, alright? And we're given that, let's see here. The first derivative is a positive, so f prime of x is going to be greater than 0, or positive plus. And f dou prime of x is going to be less than 0. So, f prime, alright, it's telling us that it's always going to be going up from the last value, okay? But dou prime means that the rate of the rate is going to go down, alright, it's negative. So, as we progress, we're going to be going up, alright, but it's going to be going up less and less, so it should look something like this. It's going to plateau, right? So, let's look at our choices here. So, we got 7 to 9, right? So that's a difference of 2. And then 9 to 12, that's a difference of 3. So, here we see that our second derivative is positive in this table, because as we progress through x, as x goes up, our rate of change goes up. Or, yeah. So yeah, it can't be A. So, now let's look at B. Alright, so we start with 7, and go to 11, right? So there's plus 4, alright? We do 11 to 4, go to 3, and then 2. So B would probably be our correct answer. So to the other ones. So right off the bat, we're going down. And so that means our first derivative would not be positive. So it can't be C. And same thing for D. Alright, so that means B is our only correct answer. Alright, moving on to 14. Alright, on the closed interval, the absolute minimum of f of x equals e to the sine x occurs at some value. All right. So, to find our absolute minimum, what points do we need to check? All right. In an interval, all right, a closed interval, we need to check our endpoints, right? So let's write some points we need to check. When x, oh, points, points, okay? So when x equals 0, and then when x equals 2 pi, right? So what other points do we need to check, right? We need to find when f prime is going to be 0 or undefined, all right? So we have f of x equals e to the sine x, right? So f prime of x, right? Chain rule, right? So first we find this thing, e to the something, or that's going to be itself, right? Times the derivative of sine x, which is going to be cosine x, right? So when is this going to be 0, right? We define cosine x times e to the sine x equals 0, right? So we know that e to anything can never be 0, right? So that means we just need to find where cosine x equals 0, right? And that's going to be 0 as pi over 2 and 3 pi over 2. Okay. So let's add those to our list. Bring these over. Boom. This is our list. Now let's plug all these in, right? So let's make a table. 0, pi over 2, pi, 3 pi. Wait, no. Pi is definitely not one of them, right? Yeah, it ain't one of them. Can I like, let me say. All right. 0, pi over 2, 3 pi over 2, 2 pi, right? Let's plug them into the original function. 0, okay. Sine of 0 is going to be 0. It's going to be e to the 0, which is just 1. All right. So, and then pi over 2, e to the sine pi over 2. Sine pi over 2 equals 1, so it's equals 1, e. And then 3 pi over 2. Sine of 3 pi over 2 is negative 1, so it's e to negative 1, or 1 over e. And then 2 pi is going to be the same as 0, so it's going to be 1. So, which of these is the least? It's going to be 3 pi over 2, 1 over e, and it's going to be c. Ooh, that's our least value.
Alright, finishing up with the last two questions. Number 16 is only like annoying one, and then I'm going to quickly go over number 15. So we got g of x, which equals x squared e to the kx. This says that k is a constant. And it's saying for what value of k does g have a critical point at x equals 2 over 3. So basically, we just want to solve for k. In order to do that, we're going to take the derivative, set equal to 0, and then plug in 2 over 3 for x, and then we can solve for k. So I'm going to show you. So I'm going to say g prime of x equals, and then we got to do product rule. So this is going to be 2x e to the kx plus x squared. Bring down the kx, and then take the derivative of that. So this will be plus kx squared e to the kx. And then I'm going to set it equal to 0. And then I'm going to plug in 2 over 3 for x. So you get 2 thirds e to the 2k over 3 plus, and then this is 2 thirds squared k e to the 2k over 3 equals 0. So this is all going to simplify to become 4 over 3 e to the 2k over 3 plus 4 over 9k e to the 2k over 3. So now all we have is the single variable k. And I'm going to solve for it. And what I'm going to do is I'm going to factor out 4 over 3 e to the 2k over 3. So 4 over 3 e to the 2k over 3. And this is just 1 plus 1 over 3k. Alright, and then remember what Alonzo said? That e to any number will never be 0. Like, it's always going to be some number, some positive number. So that means we can only focus on the equation 1 plus 1 over 3k. So you get 1/3 k equals negative 1. Multiply both sides by 3. K equals negative 3. So that's when we'll have a critical point when x is 2/3. So that means A as our answer. And then 16, the last one. It says maximum value of 2x cubed minus 15x squared plus 36x on the closed interval 0 to 4 is whatever one of these choices are. So what I'm going to do is that I'm going to take the first derivative. So that's going to be 6x squared minus 30x plus 36. Then I'm going to factor it out. Take out the 6. 6 times x squared minus 5x plus 6. And that's the same thing as 6 times x minus 3 times x minus 2. And then I'm going to take the first derivative, which we just did, set it equals 0. So that means that x equals 3 and 2. Not only that, but when we always have a question like this, you always got to include the endpoints, because those could be a possibility of the maximum in this case. So 2, 3, or yeah, 2, 3, and then 0, 4. Now, what we got to do is plug those back into the equation. Now, I'm way too lazy to do that, so I'm just going to straight up say the answers, alright? So, plug these all back into the original equation, alright? So, f of 0, that's just 0. F of 2 is just 28. F of 3 is just 27. And then f of 4 is 32. Therefore, our maximum value is 32, which is the answer is C. So, that's really it. You guys gotta lock in for this test, okay? Lock in. Everyone's gonna do good, alright? I'm glad for Alonzo and Jaden being here. Jaden, if you're here, you want to say any words to the calculus people? Alright, Jaden isn't here. What about you?
Oh, Jaden.
Jaden!
If you guys get an A, come to me for free egg roll, okay?
Okay.
All right. Let's go, Jaden. Thanks for the
Yes,
stuff.
thank you. Alright, guys.
And guys, I hope you do well in your test. It's all good, and we'll do good. All right.
Yep.
Wrap it up.
Yes. Alright, guys. Next up is Unit 6. That's all integration. Definitely a very important unit. We're gonna do good on that. Hopefully we get some positive results from this test. And then hopefully you guys have a good winter break. See you next unit. Goodbye, chat.
All right. Toodaloo.